Tires are an essential component of an airplane's landing system. Have you ever flown in an airplane? If so, you felt that funny bump when you touched down at the end of the journey, but have you ever wondered how airplane tires handle all that stress and pressure? Why don't they burst into contact with the hard runway? Well, airplane tires need to be specially designed. Thanks to their design, they're strong enough to stay intact during takeoff and landing. So in this video, we're going to tell you inside look how do plane tires survive brutal landings. The video is going to be amazing, so make sure you stick till the end. Before starting the video, be sure to smash that like button and subscribe to never miss out on any of our videos. Airplanes can't land on the belly of their fuselage, rather they must land on inflated tires that can withstand both the weight of the airplane and the friction it creates on the runway. Some airplanes contain 4 or 6 tires, whereas others contain up to 20 tires. With tires airplanes can safely take off and land, you see the shredded remnants of car tires littering the highway all the time. Yet you've almost certainly never witnessed or even read about a tire blowout on an airliner. Why not? Aircraft that weigh as much as buildings come in at 170 miles per hour on airline tires, made of basically the same materials like car tires, thousands of times every day. Airplane tires are very different from car, truck, or bicycle tires. In fact, airplane tires have about as much in common with these tires as they do with running shoes. They're all made of rubber. They all contain air. They all provide support and cushioning for what's on top of them. But that's where the similarities end. Airplane tires have to deal with enormous forces when the plane lands. They especially have to deal with friction. Friction occurs when two surfaces move against each other, like when you rub your hands together. Airplane tires create friction when they hit the runway. This friction generates heat. It also wears down the outside layer of the tire. Because of this, airplane tires are reinforced with strong, flexible materials. One of these materials is a super strong plastic called Kevlar. Kevlar is strong, flexible, heat-resistant, and lightweight. It's important for airplane tires to be flexible. Flexibility lets airplane tires absorb more of the shock of landing. Flexibility also slows the wearing down of tires. You'd think every now and then there would be a blowout. Airplane tires are made to withstand hitting the pavement at extreme speeds, all while supporting an entire commercial jet. Don't think too hard about it next time you're in the air, but 45 inches of rubber is the only thing standing between you and the tarmac during landing. Airplane tires also have conducting strips built into the tire grooves. These strips discharge any electric charges that may have built up. The tires, of which there may be up to 20 or more per aircraft, are relatively small but pump to air pressures far higher than those used on automobile tires. Some observers say that the greatest danger is not when planes land, like the United Airlines plane, but on taking off. Is it at the point of takeoff that the tires are at their maximum temperature as they've been rolled on for the length of the runway? Tires on landing, on the other hand, are at their coolest as the plane has been in the air before hitting the ground. Being the primary contact of an airplane with the ground, imagine the weight and stresses of an entire airplane borne by the airplane's wheels. You can think of an airplane wheel as an assembly of the central metallic hub and the inflatable tire installed on it. Once a pilot applies brakes, the tires scratch and screech across the runway, making sure that the airplane comes to a halt when demanded. Though it's rare, like all other equipment, airplane wheels may also fail, and that would pose a serious question. What if an airplane wheel falls off? Even though it's highly unlikely that an airplane wheel would fall off, most times commercial airplanes are still able to land with one wheel missing. For example, the Boeing B777 has 2 wheels on the nose landing gear and 6 wheels on each main landing gear, which means that it may still land normally even if one of the wheels would fall off. Airplanes use tires made of conductive rubber to neutralize electricity. Electricity is created naturally through friction, and airplane tires are exposed to a lot of friction during takeoffs and landings. The friction between an airplane's tires and the runway can lead to a buildup of electricity. When taking off, an airplane's tires may accumulate electricity that can damage the airplane's electronic components. Airplanes contain hundreds if not thousands of electrical components, many of which are highly sensitive to electrical discharge. If a stray electrical charge reaches one of these components, the component may fail. The use of conductive rubber tires prevent this from happening. Even though conductive rubber allows electricity to flow through it, it prevents the buildup of electricity. With conductive rubber tires, electricity will travel to the ground rather than accumulate in the tires. The friction-created electricity won't build up in the airplane's tires. When made of conductive rubber, the tires will expel it to the ground. Airplane tires aren't particularly large. The Boeing 737 tires measure 27 into 7.75 R15, which means they're 27 inches in diameter, 7.75 inches wide, and they're placed on a 15-inch rim. This is much smaller than a semi-truck tire, which can be over 40 inches in diameter and almost 20 inches wide. But plane tires are incredibly strong thanks to cords of nylon or a synthetic polymer called aramid that is embedded below the tread. Aviation regulations require that airliners' tires be able to withstand 4 times their rated pressure for at least 3 seconds, and the toughest tires can stand up to a landing at 288 miles per hour. It's almost impossible to blow out a tire by overinflating it, Lee Bartholomew, lead test engineer for Michelin aircraft tires, told Wired. In fact, in cases where tires have been overinflated, the wheel actually falls before the tire. Airplane tires have 6 times more pressure than car tires do. Airplane tires are more than just rubber and Kevlar. They can have 14 different parts. Each of these parts serves a specific purpose in making takeoffs and landings safer and easier. Commercial jets usually have around 20 tires and touch down about 500 times before they have to be retreaded, which can be done 7 times before the tires no better than scrap rubber. And tires at the nose of the plane tend to have shorter lifespans than the rest. It takes 2 mechanics up to an hour to change a single tire. They raise the tire only 5 centimeters off the ground, which doesn't feel like enough room to fit a thumb, let alone change a plane tire. The mechanics take off the hubcap and reduce the tire pressure from 200 to 30 psi, which reduces the risk of it exploding as the bolts and nuts holding it on the plane are removed. A sleeve protects the axle, and a lifting tool pulls the tire off. The axle sleeve is then greased and the new tire is slid smoothly on, and then things move in reverse. Nuts and bolts, tire reinflated to 200, hubcap back on, and the whole thing is gently lowered 5 centimeters back onto the ground. So what happens after 500 landings, 7 retreading, and uncountable? This is your captain speaking. A lot of the tires get recycled into playground mulch and even other tires for farming equipment. At the same time, they would avoid costly fuel dumping. However, this decision is based on multiple factors such as the airline policy, facilities available at both airports, and the airplane design itself. In an approach, if the pilot has not crossed the landing decision threshold and notices the loss of a wheel, a go-around is executed, but a tire burst or wheel loss after touchdown is difficult to handle. Especially for smaller aircraft, conductive rubber is the preferred choice of material used in the production of airplane tires. It features the same force-absorbing properties as traditional rubber, but with the added benefit of conductivity. Conductive rubber tires protect an airplane's electronics from damage caused by electrical discharge. Large commercial or cargo aircraft, such as the Airbus A380, often have more than 20 tires, providing enough stability to safely land even if one fails. Thanks to over-engineering, tires are just one more reason commercial flights are much safer than driving down the highway. Let us know your opinion in the comment section below. This was all for today. Hope you liked the video. Don't forget to subscribe to Finding Tech. Stay safe and we'll be back soon with another video.